with processing installed on our computer, we're ready to begin programming. So when we're writing code, we're going to have to pay attention to a few things, whether we use, whether things are case sensitive. Most of the code is going to be case sensitive. It's not white space sensitive. So if I put in extra returns, extra spaces, none of that will break my code in most places. So a good practice to get into when we're working is we create a comment section at the beginning of our code. So comments are done by putting in the slash. So I put in my backslash, and 2 slashes indicate it's going to be a comment. So I'm just going to put my name, and then I'll put in 2 more slashes, and then I'm going to put my date in for the day that I am working on this. And then I'm going to put in a description or title for what my project is. So when I have a more specific thing, this is going to be more generic. It's going to talk about a number of basic things, introducing some core concepts. Notice how this code is gray. Now if I start typing, this code is not gray anymore because it's not a comment. Now we put in comments in our code to provide information to us to make it more readable. Sometimes we use it as a debugging technique. We use it as a way to turn off lines of code when we're trying to figure out why something is broken in our code. So what we need to do when we are coding is, inside of processing, every program that we write is going to have 2 functions. So a function is a set of instructions that the computer is going to run. And there are 2 built-in ones that every processing sketch requires. So we start out and we put in the word void. Notice it's blue right now. And then we type the word setup, put in 2 parentheses, put in a curly brace. Curly brace is right above the return or enter key on your keyboard, and then hit return twice, put in a closing curly brace, and then use your up arrow key to go into that empty space. So it's always a good idea to put in that closing curly brace before you start putting code in it, because as our programs grow more complex and we have curly braces and nested inside of curly braces, it starts to get a little bit confusing. So it's nice to put that in there so we don't forget. And one of the first things that we can do is we can specify how big we want our program to be. And we use that with the size command. So I put in the word size. Now, the next function that is part of this, and now I'll hit return twice, and I'll say void draw, put in 2 parentheses, curly brace, return twice, closing curly brace, up arrow once. So we have setup and draw, and I'll explain the punctuation here between the parentheses and curly braces, what void means and all of that as we go, because I think it's easier when we see things happen and then go back and start dissecting what is there. Now it is important as you are working, it's a good process to get into is to save. So on Mac it's Command S, on Windows it'd be Control S, and just use that keyboard shortcut while you're working. So I hit save, now it's been saved. And if we do that, that's so that if something crashes, the power goes out, our computer gets grumpy, whatever, it means we don't have to redo the work that we just did. Now anytime you're working and you want to see what you have, you can just hit the run button. And this is part of why we're using processing versus trying to put code into a web browser. Then we're dealing with getting it to run properly in the web browser, running into other conflicts. This is all now a self-contained development environment. So everything we do here just works. So I hit the run button and we can see it now pulls up. And here is my sketch. It's 800 by 600 pixels. That's what my 2 numbers did. So 800 wide, 600 tall. So we always specify things width and height, or our X component, our first and then our y. So horizontal, then vertical. So horizontal, vertical. Anytime we're specifying locations and sizes, it's always going to be the horizontal value first, the vertical value second. So if I were to just change this number to say 300 and now hit run again, you'll see that it changed the size of it. I'm just going to go back to 600 because I like that a little bit better. Now, it's not that interesting unless we actually draw something there. We'll probably want to change our background color as well because that gray is kind of boring. So if I want to draw something, what I could do is I could just specify and choose rect, which is short for rectangle, and rectangle takes 4 values. Now it needs us to specify a location of where it's going to be. Again, remember, horizontal value first, then our vertical value, and then I specify how wide something is going to be. So I'm going to make this say 50 pixels wide, and I will say 75 pixels tall. So we have our horizontal, our X location, our Y location, our width, and our height. Now if I hit run again, you'll see that it drew a rectangle. Now it's filled with white. Our default background is filled with gray because unless we specify values, it's always going to default to those. And we can see it also defaults to a black stroke around it, a 1 pixel black stroke. But if we notice, it's now over 100 pixels. Because if I look at the width of this, I can fit it twice over here. So 50, 50, and then there's 100, that's 50 wide. And we can see that it's kind of 1.5 times as tall as it is wide, thus the 75, and it's down 200. So you play with the numbers to start to understand how they show up. Now we can also say something like ellipse, and I'll just say 400 and 300, and this one will go 100 and 200. Now if I run it, you can see it drew an ellipse. Now you'll notice this is exactly centered on my screen because by default ellipses draw from their middle where rectangles are drawing from their top left corner. So that is important when we're trying to calibrate or figure out what is the difference between objects, where are they on screen, or say I want to draw a circle inside my rectangle. We have to know what that's going to be and how that's going to work. Now, to that end, I'm going to just change this to 100 and 200. Now let's run again and watch what happens. And you'll see the ellipse is on top of the rectangle, and that's because the ellipse is specified second inside my draw function. So again, every sketch has 2 required functions. Setup, where we initialize everything, we say how big it's going to be, any variables that we're working with, which we'll be looking at very shortly, what their starting values are, and then draw is what we want to have happen approximately 60 times per second. So this is actually a running function. This isn't just happening once. This is happening about 60 times a second, depending on your computer and how many lines of instruction and how complex it is, because it's possible to make things that bring the computer to a crawl. And we'll be looking at that in upcoming sessions. But right now we can see that we're drawing these. So now if I take this line of code that I have here, and I'm going to cut it, paste it above it, run, we'll see that the ellipse is drawn first, the rectangle is drawn second. But you can see the rectangle is, its origin point is its top left corner, but that is the center of the ellipse. So it's important just to keep that in mind while we're working. I mean, we can change the mode on it where that specifies where things draw from, but I prefer to just leave it at its default and then just adapt accordingly by having to change my values on it. So that's now the beginning part of how to fit these on screen. Now if I were to say something like fill, I want to fill this with a color. So if I choose a color, now by default our fill is going to have, if I put in one value, so if I say 10 for it, and now run this, you'll see that it created a very dark value. 0 will be black. If I say 0, that's black. If I do 255, that's going to be white, which is the default. So if I go approximately halfway at 128 and run it, you'll see that it's now filled at 50% gray. Both of these are because I said fill, and it will just color whatever objects I keep drawing unless I specify a new value. So if I say here fill 200, you'll see that that rectangle is about the same color as my background. I'll just change that so it's a little bit different. 180. There, so now we have 3 different grays happening. Gray isn't the most exciting color. Normally, we want to choose an actual color. So what this technically is doing is choosing 128, 128, 128. So we're filling our red, our green, and our blue components equally. Now, the numbers go from 0 to 255 because it's based on using 8-bit color. So we have a possibility of 255 values for red, 255 for green, and 256 values, 0 to 255. So it's 256 values, 8-bit, for each of our red, green, and blue components. So if we turn red all the way on, which is 255, and if I turn green and blue all the way off, what you will see is that we have now filled it with red. If I turn green all the way on and red off, it's now green. If I turn red and green all the way on, it's going to create yellow. So we're mixing our RGB color values. So if you've played in an image editing program like Photoshop and worked with RGB values, you can move your sliders around and you can see what those values are as you work. Now we do have, inside of processing, the color selector, which you can see gives me different values. So if I wanted this kind of pinkish, magenta-ish color, we can see that's 255, 247, 219, or I can hit copy, and now I can paste that in, and it pastes in our hexadecimal value here, which is going to be a letter number combination prefaced by the hashtag or #. So now if I run my sketch, you can see it's filled with that purple color. Just move my windows around a little bit. So if you want to have more control over mixing your colors, you can do that in the color selector. And again, you could type in your RGB or your hex color values with it. Both are totally acceptable. You can use HSB values as well. You have to name it a little bit differently while you put it in. So normally though, if we want to be doing dynamic colors and changing our colors programmatically, we use RGB because we can change these values, because the values go from 0 to 255. Anything that is a number, we can change through code. That's the beauty of working with this. So anything that is a number, X, Y, width, and height, we can change through code. When we're working with the hex number, it's a little bit more challenging. We usually have to use a function that we can pass that hex value in, and it gives us back the numbers that we need. So that gets a little bit messier and we don't want to go there right now. So in the beginning, I would encourage you to just play with some of these things where now maybe instead of fill, if you remember there is stroke. And now if I wanted to choose a stroke color, let's go, yeah, mustard is gross. We'll go a little bit lighter. Paste that in. Now, you will notice at the end of each line of code, there is a semicolon. That semicolon is like putting the period at the end of a sentence. It's a required component of punctuation. So when we're doing programming, what we're really doing is it's a language. We have vocabulary, syntax, and punctuation rules that we have to follow. So vocabulary are the words that we're learning with it. The syntax is the order in which we do them and how we work with it. And the punctuation, when we use parentheses or semicolon. So that's not a colon, it's the semicolon. So it's the dot with the comma underneath it. So it's really easy when you're typing code to put in a colon. And you'll see now that I did that, it underlines it red, and it's even telling me missing operator, semicolon, or curly brace near. And so one thing that will happen is when it gives you error messages and the code says something's broken, it struggles to figure out often exactly where as our programs grow more complex. So it will tell you things you're like, but that line of code is not the problem. It's like, no, it's not, but you confused it. So it's very possible to confuse the computer while you are working with it. So now if I say stroke, and I'll draw another rectangle. This time I'll put it at width divided by 2, which in this case, notice how width turned pink. And what that means is, oh, got to finish writing all the things for rect. Width is simply half of my size. So when I use just the word width spelled out like this and nothing else in front of it, no other, what that means is I'm referring to the width of my whole sketch. Now we have a companion piece, height. Notice again that turned pink, and we'll just make this 100 and 100. Okay, now I'll do it. I'll do uneven numbers just so we can again tell which is which. Now if I run this, you'll see our stroke is now affecting all of those. But if I don't want that stroke to affect everything and I want this to be a new color, I could go stroke here, and let's just get a different, I'll grab green, copy that, close parentheses, semicolon. Now let's run my sketch. So these two should be in green, that one is in yellow. So you can see how we are changing our sizes here. Now if you want to remember how this works, we go back into our documentation reference. And now we can see under stroke there, let's just go back to stroke and we can see information about stroke. And if I look under related, we'll see something like, ooh, stroke weight. What's that? Now we can see stroke weight allows me to change the size of my stroke. So let's go back into my sketch and stroke weight. Now notice I have in my command two words together. One is capitalized and it's the first letter of the second word. And that method of capitalization is called camel casing. It's like the hump on a camel. So anytime we put multiple words together, and I did that even when I named my project, we capitalize the first letter in the second word. One, in our own code, it makes it easier to read, because if I do it like this, stroke Q8 because our brain will then group together letter combos that we recognize. But by putting that word in capitalized like that, we now see it as one word and two words. So camel casing is part of how most modern languages are written. And when we name our own values for variables and functions and things like that, we will always use camel casing as our method as well. So I'm just going to save since I've typed a bunch of stuff and I want to retype it. Now I can hit the run button using Control or Command R. You'll notice now my strokes got fatter because I chose stroke weight 4, making it a little bit easier to see them. So when we use the reference, we can use it to learn a little bit more. We may discover things that we weren't aware of before as we look at it, and it will give us more insight. Now, as I said, white space doesn't affect the code. So now what I could do is separate each of these objects here. Oh, that's not where I want to separate it. I want to separate it here. So we can see object 1, object 2, object 3. Maybe this object wants a different fill. So I'll go choose another fill. Let's see. So if I have a yellow stroke, we're going to go with a different purple here. Paste that color in, close parenthesis, semicolon. Now rerun it. So now we have our different colors. You can see there it is. But notice how by using the white space, I've made my code much more human readable. And there's kind of two ways that people write code. Is in the beginning you do it very verbose and you make it very human readable. As you become more efficient, you may condense some things. But the reality is, if you're in a professional setting and do programming, at some point someone else is going to have to read your code. If you're in an educational setting, it's your instructor. And if you make your code more readable for them, it's much easier for them to understand what you were doing, what your thought process was, what you were attempting to achieve, or if there's problems, to read the code and find where they are. So it's really important as we work to endeavor to do that. Now, you may find when you're working at times that your indentations get all out of whack and you're like, wow, my code is just really messy looking. And as we do this, under Edit, we have an option called Auto Format. Controller Command T. If I select that, it formats it. So that's really useful. Something else that's also going to be really useful, if I don't want the stroke weight but don't want to delete it because maybe I want it back later, is I can turn it to a comment. Now I can just put 2 slashes. You see it's gray now, it's a comment. So if I run that, my stroke weight will be back to the default 1. But instead of manually typing those in, if I use Command or Control, so again, on a Mac it's Command, on Windows it'd be Control, and then the slash key, it comments it. That's great. And if I click anywhere in this line and use the same keystroke, it uncomments it. So I don't have to highlight all of it and then comment it. All I have to do is click in a line, comment, uncomment. I can even highlight like this. See, I didn't even select whole lines. Comment, all of those get commented out. And now if I just highlight within them again, notice, I'm randomly selecting lines like that. So I can comment and uncomment very quickly. So you'll see me do that in later videos when we're analyzing things, debugging, troubleshooting, figuring stuff out. There'll be large sections where we'll highlight and comment or uncomment it, and I do it very quickly. I don't go onto each line of code and type it in, and then go, oh, I want to undo that. So delete. That's really tedious. That's just no fun. Auto format, make sure it's all nice and clean. So get in the habit of trying to keep your code clean while you type it. And as you work with it, use auto format a lot. If your auto format breaks when you do something, chances are there's something wrong in your code and you're going to have to fix it anyway, so it's a good practice to get into. All right. Well, there's some of the basics. Start exploring, look through the reference documents, add some more things, and see what else you can do. Good luck and have fun.